Today we are going to discuss about reflection of light at curved surface lesson. Draw a line segment AB across the middle. This line segment should be considered a plane surface. Draw another straight line at right angle to segment AB. The second line should bisect segment AB at point O. We shall call this ON line as normal. Draw a straight line making certain angle with ON. This straight line should be called incident ray. Another line should be drawn from O point. This line should be considered as a reflected ray. An angle is formed here. This angle is called angle of incidence. Here another angle is formed. This angle is called angle of reflection. We observe that the angle of incidence is equal to angle of reflection. The first law of reflection tells us a light ray incident at an angle with the normal at the point of incidence will get reflected making equal angle with the normal. So, angle of incidence is equal to angle of reflection. Angle of I is equal to angle of R. Now, let us know about curved mirrors and also apply first law of reflection. First, let me explain concave mirror. For a concave mirror, all normals will converge towards a point. This point is called center of curvature. The midpoint of the mirror is called pole. The horizontal line which passes through the center of curvature and pole is called principal axis of the mirror. The distance between P and C is radius of curvature. I am drawing parallel light rays. The light rays are hit the mirror and come back. All the reflected rays join at the point. This point is called focus or focal point. Definition: the rays coming from an object parallel to the principal axis after reflection seems to cross the principal axis at nearly the same point. This point where the reflected rays converge is called the focus or focal point of the mirror. The distance between pole and focus point of mirror is called focal length. The radius of curvature will be twice this distance. So, R is equal to 2F. And also, F is equal to R by 2. Draw the incident ray and reflector ray. Draw the normal from center of curvature to incidence point. There are two angles are formed, angle of incidence and angle of reflection. We observe that angle of incidence is equal to angle of reflection. Here also, first law of reflection is followed. For example, angle of incidence is equal to 30 degrees. What is the angle of reflection? So, angle of phi is equal to angle of phi. So, angle of reflection also 30 degrees. The next topic is image formation by concave mirror. Object is placed behind C. The first incident ray is parallel to the principal axis and it passes through the focus after reflection. The second incident ray is passing through the focus point and it becomes parallel to the principal axis after reflection. These two reflector rays are converging rays and they intersect with each other in the space between center of curvature and focus point. The image is formed between center of curvature and focus point. And second one, the image is real and inverted. And third one, the size of the image is smaller than size of the object. You can say image is diminished. Object at center of curvature. The first incident ray is parallel to the principal axis and it passes to the focus after reflection. The second incident ray is passing through the focus point and it becomes parallel to the principal axis after reflection. These two reflected rays are converging rays and they intersect with each other near the center of curvature. So, we can conclude that when an object is placed at C, the image is also formed at C. Size of the image is equal to size of the object. Image is real and inverted. If the object is between F and C, the first incident ray is parallel to the principal axis and it passes through the focus after reflection. Second incident ray is passing through the focus point and it becomes parallel to the principal axis after reflection. These two reflector rays are converging rays and they intersect with each other behind C. So, we can conclude that when an object is between F and C, the image is formed behind C. Image is enlarged, real and inverted. Object is at a focus point. The first incident ray is parallel to the principal axis. It passes through the focus after reflection. The second incident ray, which is passing through the top of the object, is also passing through the center of curvature of the mirror. Since this incident ray passing through center of curvature, it will bounce back after reflection following the same path. These two reflected rays are parallel to each other, so the image is formed at infinity. Object is between P and F. The first incident ray is parallel to the principal axis. It passes through the focus after reflection. The second incident ray, which is passing through the top of the object, is also passing through the center of curvature of the mirror. Since this incident ray passing through center of curvature, it will bounce back after reflection. We notice that the two reflector rays diverge and will not meet. This ray diagram tells us that since the reflector rays are diverging, we will not get an image anywhere. So we extended the reflector rays backwards till they meet. They appear to be coming from one point. This image that we get by extending the rays backwards is called virtual image. So the image is virtual image, erect image, and enlarged image. How this magnification is helping us to find out the nature of the image formed by the spherical mirrors. If magnification is positive, then it is a virtual and erect image. Magnification is negative, then it is real and inverted image. M is equal to 1, then it is height of the object is equal to height of the image. If m less than 1, diminished. If greater than 1, magnified or enlarged. For example, m is equal to plus 1, then it is virtual erect. Why? Because positive means virtual and erect. Equal 1 means same size image. So virtual, erect and same size image. Next, m is less than plus 1. Virtual, erect and diminished image. M is greater than plus 1. Virtual, erect and magnified image. M is equal to minus 1. Real, invert and same size image. M less than minus 1. Real, invert, diminished image. M greater than minus 1. Real, invert and magnified image.